So this video is about correlation versus causation. When we find a correlation between two variables, it's very tempting to say that one causes the other, but we cannot say that unless we know for sure. Here's a good example. So, pirates and global warming. As you can see, the average global temperature decreases as the estimated number of pirates in the world increases. So, that's easy then. Global warming is caused by a lack of pirates. What we need is more pirates. Then the global temperature will go down. Because as you can see, as the number of pirates increases, the average global temperature decreases. There's a negative correlation between the number of pirates and the average global temperature. However, I think most of us can probably agree that the number of pirates really does not have any effect on the average global temperature. So why would we ever say that there is? Because a lot of times when we see a correlation, we come to the conclusion that one is causing the other. But what we have here is a confounding or lurking variable. Confounding and lurking variables are actually different from each other, but for our purposes, we're going to use the terms interchangeably. A confounding variable is a variable that is affecting both the independent and dependent variables. Do pirates really have an effect on global temperature? No. So then why does there seem to be a correlation between the two variables? Well, because of time. Both variables are related to time. As time goes by, global temperature goes up and the number of pirates goes down. So the confounding variable in this example is time. Here's another example. Milk does a body bad? Did you know that studies have revealed that milk consumption is negatively correlated with height? In other words, people who drink more milk are shorter than those who don't. But this seems backwards. Here's a scatter plot. The amount of milk consumed per day is increasing, but the height is decreasing. There's a negative correlation here. This seems backwards. Milk is supposed to help us grow, but this makes it look like milk causes us to shrink. What is the lurking variable here? In order to answer that question, we have to think, what could cause someone to drink more milk and be short? Simple. Age. Kids tend to drink more milk than adults, and kids tend to be shorter than adults. Age is the lurking variable here. Sometimes we see a correlation, but it's just coincidence. For example, there's a very strong correlation between American consumption of cheese and the number of people who die by being tangled in their bed sheets. In fact, this has a correlation coefficient R of 0.96, almost perfectly correlated. But it's just a coincidence. There is not any connection between how much cheese Americans eat and how many people die by being tangled in their bed sheets per year. This is just a coincidence. So just because we get a very strong correlation, it does not mean that there's any link between them at all. And if there is, it might mean that there is a lurking variable, or one might actually be causing the other.